this video lecture I will discuss about the Schrodinger's equations. Those are basically of two types. One is time independent Schrodinger equation and second is the time dependent Schrodinger equation. The Schrodinger equation was discovered in 1926 by Erwin Schrodinger, an Austrian theoretical physicist. It is an important equation that is fundamental to quantum mechanics. These equations basically provide the wave function of the particle, and wave function is associated with the particle with microscopic system, right? So in earlier video we have seen about the matter waves, right? So here Schrodinger basically use the concept of wave packet and successfully explain the energy of complex systems by using these two equations. So in this section, the first one is time independent Schrodinger equations. Before I go into the mathematical portion or derivation of these two equations, the importance of these two equations are that with the help of these equations one can find out the exact wave function of the particle. Because of that one can find out the energy state of that particular material particle in microscopic system, right? So what will be the momentum, what will be the average position, what will be the energy state, all these information about the particle one can find out using the Schrodinger equation. And these are of two types. Number one is time independent Schrodinger equation and number two is time dependent Schrodinger equation. How one can derive the Schrodinger equation? That is basically shown here in a systematic way. So first of all, the time independent Schrodinger equation, right? To consider a system of stationary waves associated with a moving particle. So stationary waves are here basically that is a group of waves that is associated with a moving particle. Again the same concept of de Broglie wave, matter waves. So the wave function is associated with particle that basically provide the information of matter waves. The wave equation, del square psi is equal to 1 upon u square del 2 psi upon del t square. Right now this del square is the Laplacian operator, and I am considering here one dimensional case. So for that del square is written in left hand side by this way, del 2 psi upon del x square is equal to 1 upon u square into del 2 psi upon del t square, where u is the velocity of the wave and psi is the wave function that is associated with a particle, right? So now psi is function of x and t. In this case that is defined with this plane wave solution, that is a naught into e iota kx minus omega t. If I divide by this exponential part in x variable and t separate by this exponential term is separated by this way, so one is exponential term with iota kx and second one is this minus iota omega t. So this combined form a naught e I kx is represented by psi naught, that is the function of x, and the next remaining part is function of t, exponential term minus I omega t. So this is the product of two. One is the spatial coordinate and second is with of time. So this psi is function of x and t. Right, this can be written as psi naught x into e exponential part, that is e minus iota omega t. So this is the wave function in one dimensional case, and now I am differentiating it twice with respect to t. So this will be equal to d2 psi upon dt square is equal to minus omega square psi naught x e raised power minus iota omega t, and this part is equal to psi. So this becomes minus omega square psi. So this value del 2 psi upon del t square is the right hand side of this wave equation. Del 2 psi is equal to 1 upon u square del 2 psi upon del t square, and I am considering it one dimensional case, so that is along the x-axis, so this can be written as in this way. Right, so first of all what I did, I just define the wave function, and now this d2 psi upon d2 square is equal to minus omega square psi. That value I am putting in this equation. So d2 psi upon dx square is equal to 1 upon u square minus omega square psi. And after simplification this can be written as minus omega square upon u square psi, and that can be written as minus omega upon u whole square psi. So I have to find out the value of omega upon u, because we know that omega is equal to 2 pi nu, and nu is equal to u upon lambda, where u is the speed velocity of the wave. So omega upon u is equal to 2 pi by lambda. So I am putting this value of omega upon u in this equation here. So my equation becomes del 2 psi upon del x square is equal to minus 4 pi square upon lambda square psi. Again by using this de Broglie wave concept, that lambda is equal to h upon mv. I am putting this value of lambda h upon mv here at this particular place. So this equation becomes del square psi upon del x square is equal to minus 4 pi square m square v square upon h square into psi. Now I am introducing the concept of total energy, kinetic energy and potential energy, because at one place in this equation I have observed this m square v square, right? So in the next slide I will define this m square v square. So we know that kinetic energy is equal to the difference between the total energy and the potential energy. So what I did, I just multiply it by m and divide by m. So this is equal to m square v square upon 2m, that is equal to E minus V. So I have to find out the value of m square v square, so that is equal to 2m E minus V. Now I am putting this value into the earlier equation, so that is basically here. So d2 psi upon dx square is equal to minus 4 pi square upon h square into the value of it, m square v square, that is now m and square this 2m E minus V. So I have put this value here, and the psi, after simplification it becomes minus 8 pi square m upon h square, which further can be written as because we know that h cross square is equal to h upon 2 pi. This h cross is equal to h upon 2 pi, where h is the Planck constant. So this is 2 pi. H cross is equal to h upon 2 pi. Here h is square upon 4 pi square is equal to h cross square into 2m. So you can write it 4 pi square into 2m. So this can be written as del square psi upon del x square plus 2m upon h cross square E minus v psi is equal to 0. So this is our time independent Schrodinger equation. But if suppose I have to write this for a free particle means that particle can move here and there, that is not bound. So it means v is equal to 0. So in this case the time independent Schrodinger equation becomes like this: del square psi upon del x square plus 2m E upon h cross square psi is equal to 0. Now the second part of the Schrodinger equation, that is the time dependent Schrodinger equation, in which a plane wave basically is used to describe the wave function. To psi rt, this in 3-dimensional space is equal to a e exponential term iota k dot r minus omega t. So this psi basically represent the periodic displacement for the waves, right? So with the amplitude of a, where wavelength is equal to 2 pi by k, travel into the direction of wave vector. So this displacement travel into the direction of wave vector with the phase velocity omega upon k. So this is phase velocity, or you can say wave velocity, right? Suppose wave propagate along the positive x direction, it means vector k is equal to magnitude of this k and unit vector x, right? So this k dot r, in that case you can write it kx. So the case is like this one: psi xt is equal to a exponential term iota kx minus omega t. Now what I am doing here, I am just converting this k and omega in terms of the momentum and energy by this way, right? So the second form of this equation, that plane wave basically is this: psi xt is equal to a exponential term iota upon h cross px minus et. How basically this result I have achieved? This result came from these two relations, where p is equal to h cross k. I can find out the value of k is equal to p upon h cross. E is equal to h cross omega, that is omega is equal to e upon h cross. Put this value k and omega in this equation, so it becomes k is equal to p upon h cross. So px upon h cross, omega is equal to e upon h cross, so e t upon h cross. So 1 upon h cross take out common, so this becomes I upon h cross. Here px and this is et. So you can obtain this particular result: iota upon h cross px minus et. So this is the wave function for the time dependent Schrodinger equation, which is obtained from using the idea of momentum and energy of a particle, right? So now first of all, psi is defined by this way: psi xt is equal to a e iota upon h cross px minus et. Now differentiate it with respect to time, so the result will be minus iota e upon h cross. You are differentiating it with respect to time, so this minus e I upon h cross comes out, and rest of the part will remain same. So this is your psi, which you define here. right? So d psi upon dt is equal to minus I e upon h cross psi, that defined basically here. So now I am rearranging the term, so multiply it by I and this factor, numerator and denominator multiply by I, so this is I square is equal to minus 1 minus plus, so this is I h cross. So I am taking this I h cross left hand side, so it becomes in this form, I h cross del psi upon del t, and remaining part will be this e and this psi. So here I can write this e and this vector as it is, which becomes e psi. So now left hand side is iota h cross del psi upon del t is equal to e psi. This is equation number 4. Now I am differentiating this particular equation number 3 with respect to x. Right, when I am differentiating this with respect to x, so this term p and iota upon h cross comes out. So that is basically this particular result, iota p upon h cross and this exponential term with this amplitude constant. So second derivative of it with respect to position x coordinate, the result becomes this I square p square upon h cross square, and this term where I square is equal to minus 1, so that minus p square upon h cross square, this is our psi, so this can be written as by this way. So minus h cross square, rearranging the term, left hand side, our left hand side, this is equal to minus p square upon h cross square psi, so this can be written as minus h cross square del 2 psi upon del x square is equal to p square psi, and divided both side by 2m, so minus h cross square upon 2m this, and d2 psi upon dx square, again here divided by 2m, so this is equal to p square upon 2m. So in this equation, if you see it careful, this is p square upon 2m, that is the kinetic energy of a non-relativistic particle. So I am writing it basically in this way. Here this p square upon 2m is the kinetic energy, that is 1 by 2 mv square, that is E basically. So instead of p square upon 2m, one can write E psi. So this is minus h cross square upon 2m del square psi del upon del x square, and in the right hand side you see it is E psi. So now from this equation and the earlier one, this one, equation number 4, you have seen that this is E psi is equal to iota h cross del psi upon del t. So one can compare both equation 4 and this equation 5b. So here when I compare these two equations, I found that minus h cross square upon 2m del 2 psi upon del x square is equal to iota h cross del psi upon del t. Right, so this is one dimensional time dependent Schrodinger equation for a particle. There is no potential, right? V is equal to 0 here in this particular equation. This is time dependent Schrodinger equation, and from this equation one can conclude the energy and momentum operator also. These are energy operator can be written as E is equal to iota h cross del upon del t, and momentum operator with negative sign iota h cross del upon del x. So these are two energy and momentum operator. And further in terms of the potential energy, if suppose the particle is not free, it is bound by the potential energy V, then total energy one can define in terms of the kinetic energy and potential energy. So E for a non-relativistic particle, this E is equal to p square upon 2m plus potential energy, because this is the kinetic energy, this is the potential energy, in sum of these two is the total energy. and because potential energy function does not depends on P and E, this potential V which we have defined here does not depend on the momentum and energy of a particle. Right, suppose an electron is revolving in a particular orbit, its Coulomb potential basically does not depends on the speed V. It does not depends on the energy of the particle. Right, so here this potential energy function is independent from the P and E. So the wave function basically psi should satisfy this condition. So one can multiply basically this E psi is equal to, this is sum of these two energy multiply by psi by this way. So E psi, you know that is equal to iota h cross del psi upon del t, and p square upon 2m, that is basically if I use here energy and momentum operator. So E is equal to this iota h cross del psi upon del t, P is equal to minus iota h cross del upon del x, and the square of that, and then after dividing by 2m, when I will square of it, P square, that becomes positive I square h cross square del square upon del x square, and after that divided by 2m, so this is equal to minus h cross square upon 2m del square upon del x square. So this is in terms of the partial differentiation from the kinetic energy term, right? So this is also kinetic energy term. So here instead of this p square upon 2m, one can write this minus h cross square upon 2m del square upon this del x square plus Vr psi. So now multiplying it or expand it with respect to this psi, so this function psi contribute here and this psi with. So this is our time dependent Schrodinger equation, right? So further in terms of Hamiltonian operator is defined by this H is kinetic energy plus potential energy. Left hand side of this Schrodinger equation, that is time dependent Schrodinger equation, this kinetic energy term and potential energy term is defined by psi. So psi H is Hamiltonian operator, that is sum of the kinetic energy and potential energy, right? P square upon 2m plus V, this is the result for the Hamiltonian operator. So here we have seen two equations of the Schrodinger. One was the time independent and second is the time dependent, on the basis of simple mathematical concepts. Thanks for watching this video. If you have any doubt or problem related to these concepts, you can ask me by writing the message below this video.